Hello, welcome again to all of you. Now I'm going to the my next video, which is on the evaluation of area using double integration. Now this is one of the simplest application of double integration. How you can find out area of some region using double integration that we are going to discuss in this video. So suppose I have got a region. I'm taking deliberately a rectangle. It's a simple, we all know that we can find its area by direct formula, but how the double integration can contribute over here. This is a rectangle. Suppose this point is x is equal to a, this point is x is equal to b, and at this point y is equal to c, and here y is equal to d. Okay, so this is y is equal to d, this is y is equal to c, this is x is equal to a, this is x is equal to b. Now you want to find out area of this rectangular region using double integration. Okay, so in the double integration, what we do, the region in whose area I have to calculate, we first take a small patch whose width is dx, height is dy. So what will be the area of this patch? Simple formula of area of a rectangle is length into breadth, dx dy. You can write dy dx, it doesn't make much difference because length into breadth I write, or I write breadth into length will do. So this dx dy gives me area of this rectangular patch. Now if I integrate this rectangular patch, or I should say that if I integrate the area of this rectangular patch on this strip, vertical strip, I have taken vertical strip, so the vertical strip starts from y is equal to c to y is equal to d. So y is equal to c to y is equal to d. If I'm integrating this area of rectangular patch, that means I'm making these kind of so many patch on this vertical strip and adding the area of all of it. So by doing my first integration with y, when I'll be doing this integration, I will be treating dx as a constant quantity. So only I'll be integrating dy and it will give me y. So integration of dy is y from c to d. Dx is kept as it is because it was treated as a constant thing at that moment when I'm doing this integration. So this is d minus c dx. So this integration I did on this vertical strip, I got the area of that strip. Now these kind of strip, how many I can make from x is equal to a to x is equal to b. If I add the area of all these strips, I will get the area of this rectangular patch. So I will be integrating this from x is equal to a to x is equal to b. This implies d minus c. I'll be integrating dx, that will give me x from x is equal to a to x is equal to b. So it is d minus c into b minus a. So exactly if you look at this, it is giving me the area of the rectangle. Area of rectangle. So we can conclude from this that if I want to find out area of any region, so we have to integrate only dx into dy on that region. My purpose of writing region over here is this limit will be decided by the region, but integration will be doing only of dx dy. This becomes the formula for finding the area of any region. Now let's take another example. let's make it 1. We take one another example where I want to find out the area of a region. Find the area of the region bounded by the lines y is 2 plus x, y is 2 minus x, and x is equal to 5. Let's come to the solution of it. So first of all, if I have to find out the area of the region, I have to plot that region which is bounded by all these three curves. Y is equal to 2 plus x. If I compare it with y is equal to mx plus c, so its m is positive and its value is 1. So if m is 1, the slope is 45 degree. So this line will be definitely have a positive slope, so it will be like this. Okay, and its y is equal to mx plus c. So if we take where this line is cutting x-axis, if I want to find out, I'll be putting y is equal to 0. So if I put y is equal to 0, I'll be getting x is equal to minus 2. So minus 2 comma 0. And if I'm putting x is 0 to find out where this line is cutting y-axis, then I'll be getting y is equal to 2. So if I connect these two, this line will go like this. This point is 0 comma 2. Now where this line is intersecting, this line will be intersecting at x is equal to 2 and y-axis it will be definitely cutting at 0 comma 2, because at y-axis if I put this x 0, so y is coming 2. Now x is equal to 5 line will be somewhere parallel to y-axis, this x is equal to 5. Now the region which is bounded by all these three is actually this region, this region. If I want to find out area of this region, so on that region I have to integrate dx dy. Now to integrate dx dy on this region, if I take horizontal strip, suppose this is this pen which I kept it is my horizontal strip. So in this part of the region, the horizontal strip start from this slant line and goes to this slant line. So my, if I make my horizontal strip, its limit will be from one slant line to the this vertical line, whereas in this region my limit will be from another slant line to this line. So here my horizontal strip will have different limit, here my horizontal strip will have different limit. Now this double integration follows the linearity, so I can do the integration in this region and do the integration in this region and add both of it. So I have to do the two part of the integration. Whereas if I take vertical strip, the strip starts from this slant line and goes to this slant line, this slant line to this slant line, here to here. And this I will be moving from here to here horizontally. Bounded between these two lines, I'll move it from here to here to cover the entire region. So I'll be doing only one integration. So in this problem, I will take vertical strip, because vertical strip if I take, I will be doing only one integration to cover the entire region. So it starts from y is equal to, what is this lower lines equation? Y is 2 minus x, goes to y is 2 plus x, and that will move from x is equal to 0. This vertical strip, I'll moving from x is equal to 0 to x is equal to 5. Since by this limit it is bounded between those two lines. Now this is 0 to 5. I do my first integration with y, so it is y 2 minus x to 2 plus x dx. It is 0 to 5. 2 plus x minus 2 plus x dx. So it is 2x. 2x integration will be x square 0 to 5. So it is 25. This is the answer. This is the area of this region which is bounded by these three curves.